Hey, Bogdan here, another video, linear functions. In this video, we'll show you that you can have a set of data, and by observing patterns, you can determine if the set of data is linear or not. Let's dive in. So this is the beautiful example right in front of you where it says a small plant measures 9 centimeters at day 2. So that's sort of the height on the second day. And the height is 18 centimeters at day 5. So this is the information that is provided. At the second day, the height was 9. At the 5th day, the height is 18. And down below, it says that the plant grows at constant rate each day. So this is very, very important key information. Constant rate. So each day passes by and the height would increase by the same number. So the objective here is build a table of days versus height and determine whether the pattern is linear by checking finite differences. So far, the question provides day 2 and the height, and then day 5 and a different height. So at least we can start with those 2 points, and by observing that the rate of change is constant, we can fill in the missing days. For example, day 1, 2, 3, 4, 5. Okay. So this is what we have to do. Build the tables, calculate the first differences, determine whether it's linear, and explain why this is linear, if it is linear. So, the table. Table is simply starting with a T-chart, right? Letter T, and then you have one set of data, another set of data. This is independent variable, and this is dependent variable sets of data. So, days in the first column. Please note, 2 and 9 is given. So in the second row, the entry shows 2, the day 2, and then the height number, 9 centimeters. And there's an empty space, and we can fill in definitely 5 and 18. So this is how you start. Hopefully this makes sense for now. Now, knowing that the rate of change is constant, we can find what is the difference in height between day 2 and day 5 by subtracting 18 minus 9 gives you 9. So this is the difference in height over the course of those days. And the difference in days from day 5 minus day 2, so 3 days apart, and the plant grew by 9. So how do you find the rate of growth? You divided 9, divide by 3, and you get 3. So this is the rate of change. Each day, the plant grows by 3 centimeters. So that's the constant rate of change that they did provide to us. Not numerical value, but they said that the rate of growth is constant. So from 9, by adding 3, so next day, on day 3, the height is 12. Similarly, you would use the same idea. The next day, day 4, you add 3, so you get 15. And then 5 is 18, obviously that's given. So now we have a beautiful chart where you have this first column, set of numbers, changing by the same constant. So you go from 1 to 2, 2 to 3. So this is continuous change by the same distance, by the same amount, by the same value. This is very, very important so that the first column changes. Whether they go up or down, it doesn't matter. But they have to change by the same difference. If it's not, then you cannot predict anything from the data. Now, the height column is determined by the rate of change. So if the First day is 6 because we go down from 9 by 3. Then the next day is 9. The following day is 12, 15, 18. And you can predict that on the 6th day, for example, the height will be 21 because you would add 3. So once you have the data in the first and the second column, so column 1 is done, column 2 is calculated nicely, then we go to the first differences column. In column 3, you calculate first differences. So how this is achieved? You do the second entry and you subtract the first entry. So this is how you see it, 9 minus 6. Then you do 12 minus 9. The entry number 3 minus the second entry. Boom. It is 3 again. And as you can see, 12 minus 15 minus 12, it is 3. 18 minus 15, again, is 3. So continuously, the first difference is the same number. So this is the time for you and I to say that the constant differences predict that the pattern given by those points must be linear. So this is how you determine from the first differences. If you get them equal each time you calculate first differences, if they are equal, therefore the set of points would form a straight line. And when you start learning more and more about linear functions, you would understand the following, that the straight line forms a graph of a linear function. The slope concept that will be covered in next videos represents the constant rate of change. The constant rate of change that was provided because we calculated 3 centimeters per day. And then there is y-intercept, of course, you're going to learn about it. So this is how the first differences are being applied to determine where the 2 points that were given, plus the indication that the change was constant if the points were to create a straight line. And now you see this in graphical application. Thanks to Desmos, we could create a table of values, and then you'll see those points. The given points first, right? They were provided 2 and 9 and 5 and 18. And then when we inserted the other numbers from the table of values, you observe now clearly, you can see that those numbers follow that linear pattern. So this is the linear function that you're beginning to learn about. And the rate of change from 0, 1 day passed by, the height was 3, now it's 6. The following day, you add 3 from 6 to 9. This is the step pattern. From 9, add 3, you get 12. Another day, add 3, 15, and so on and so forth. So hopefully now you get the idea. The first differences are constant. The increase is always 3 centimeters per day. So we did determine that the points on that from the chart would form a straight line. So we know how to do the table and create the first differences now. We found what is the constant rate of change. And we confirmed that this is a fixed number, 3 centimeters per day. And then the rate becomes the slope. And that concept will be discussed in the next lesson. So thanks for watching. Hopefully this makes sense now. Before you go, don't get too lazy. Do the practice question. Create table of values, find the first differences, and make sure that you solidify your learning. I'll see you next time.